I'm gonna start out with a story about a friend I have. So my friend has a problem. Every morning he has to get out of bed, and it's freaking hard for him to get out of bed. He just can't get out. And his girlfriend is yelling at him, "Come on, get out of bed, get up." And she's, "I'm not your mother," and it's really bad for him. He's at this point working as an enterprise architect in a company that does software as a service, a big one. They've got mainframe, they've got waterfall development, V-model. They deploy once every 3 months, something like that. And it's generally a very bad situation for the development process. A lot of grinding gears, very slow, as you can probably imagine. So my friend ends up actually getting stress symptoms from the pressure that's put on the people at this company. He tries to introduce something like Jira or some kind of system for managing tasks, and he's told, we don't want to confuse the developers with yet another system. So also the project management and stuff like that is a mess at this place, and it actually starts to affect his health. So what he does is he calls in sick from the stress symptoms, and he looks for another job. And he gets a new job. And from almost the first day at this new job, he gets up every morning at 8 o'clock, sometimes before 8 o'clock, at 6:30, sometimes before the alarm goes off, and he's completely revitalized. And he thought he was a bee person that had a hard time getting up in the morning. Turns out it was just the software process at the place he was working that was the problem, and it wasn't him. So why am I telling this story? This demonstrates how important the software development process is. It's really affecting people's lives and ultimately their health if you don't have a good software development process that people can thrive in and produce results. And I know this story is true because it was actually me. So, I'm just going to go through some of the things about why we want to do continuous delivery. These are the things if you look on the internet and read about it, you can read all kinds of good stuff that you can get from this. This is like the pot of gold. We're going to chase all the good stuff we want. So what's good about continuous delivery? Well, speed. Of course, if you develop a feature and the second you're done, you deploy it to production or make it move up the chain, that's of course natural. That has higher speed than having to wait to synchronize some kind of release and waiting for some QA or testing or something. If you can deploy it right away, that goes without saying, that's faster. Quality. When you have a piece of a story you're working on, you develop it and you push it to production, immediately, if you don't have to wait for the release, like 14 days or whatever, or a quarter, you get feedback immediately, because bugs do happen. And when they happen in production, it was just the thing you were just working on. And you can fix it really fast, because you can also deploy the fix fast. So this whole release train makes it possible to discover the bugs much faster and fix them faster. And when you're doing QA and testing on the work you've done, you don't have to test like 10 people's work for 2 weeks. You can test just one little thing that you've worked on, maybe one developer for 1 day, or one developer for 1 week, and then you can deploy it. So quality, as with any process, can be adjusted, of course, with continuous delivery. So you can add more quality checks, you can add more QA, you can add more testing before the thing goes to production. But inherently in the process, if you read what's supposed to happen is you get better quality. Scale. So because you don't need to plan and coordinate a release across all the developers, but each developer is taking their stuff to production at a much faster pace, that means you don't have to coordinate the release. And that kind of thing also means that you can work more in parallel. And ultimately, that will mean that if you're having problems scaling your team of developers on the software you're working on, introducing continuous delivery will actually allow you to have a bigger team without the same amount of problems. Focus is a good thing for the developer, not having to do context switching back and forth between tasks and working on a release. So also the no need to coordinate this whole release thing is letting the developer spend time on one thing at a time and focus on that. And ultimately that leads to less stress. So this has the most impact with focus on QAs and developers. They get a chance to really focus on what they're working on. And that's of course a good thing. Price, as it always boils down to in some way or form. So this continuous delivery promises higher throughput because of the less coordination and the less need for meetings and stuff like that. So it becomes cheaper to take your idea from idea to being in production. I know some people who really want that. Recruitment. So when you tell a guy at the job interview, yeah, come work for us, we deploy once every quarter, or you tell him like we do, come work with us, on your first day you're going to deploy to production. If you had some experience in software industry, you will know what that kind of thing can feel like, being in the releasing once a quarter and being told we can release the day you start, you release something to production. That actually helps you hire good talent. So in summing up, continuous delivery delivers solutions cheaper, faster, with better quality, with bigger and better teams, with more focused and less stressed employees. Does it sound good? That's the stuff we want. This is the pot of gold we're chasing. So this is an example where these people have been told to drive around in circles and keep an even pace and just drive around steady. And this is the kind of thing that's going to happen when you have, this is like the software process with releases, when you're not doing continuous delivery. See, they're starting to pile up here, and here there's big holes. Now it's getting worse, and these people are waiting. This is the release. Oh, and these guys are having to speed up really fast and run really fast, and now it's almost they're stopping here. This guy is actually not moving at all, and there's like a wave moving through here. This is the kind of thing you want to look for in your development process, like queues, stuff waiting, people being frustrated, having to wait for others. This is what we don't want, and this is what continuous delivery can remove. So I'll get back to more about the queues and the frustration they give. So I'm now going to give a small introduction to where we were before we started doing continuous delivery, just so, because everybody is at a different place. All of you are at a different place right now. So just for you to understand how we moved to continuous delivery and what that process meant for us, I'm going to give a baseline to where we started. And the general thing about this whole talk is I'm just telling you what we did and how we did it and what worked for us. A lot of it you may think doesn't completely apply to you, and some of it you may even think is crap. I'm not here to tell you how to do it. I'm just here to tell our story, so hopefully you can get some inspiration from that. So we were doing 14-day sprints, super busy, doing features, fixing bugs, PO always wanting more. And the CTO was like, can we do continuous delivery? He had heard about the pot of gold, right? He wanted continuous delivery. That sounds really good. Cheaper, faster, better. And I was like, yeah, but then I've been to some talks about continuous delivery. I've heard what they said. So I was like, we need to focus on monitoring production so we can react quickly if stuff happens. We need to, a whole IT architecture needs to be geared towards doing continuous delivery, microservices and stuff like that. We were already doing microservices, but we just needed to focus on it. And the continuous delivery means that you change the development process for everybody. And in order for us to do that, we need to actually set an ambitious goal and say we're going to do this. I was not team lead at this point. So some of the other things we were doing at that time, this is our version control. So we had 2 long-lived branches here. Time is going downwards, time is going forward. So here we have feature 1, a commit. The dot is a commit. Each dot is a commit. So feature 1, 2, and 3, they're in the first release. And just in between each other, people working on features are just all committing to master on top of each other. And at some point we say, okay, now we have a release candidate. We're gonna make this, polish this, and make it ready for production. So we merge it to the release branch, and then we do some bug fixing, maturing that release candidate until it's ready. Every time you do bug fixing, you need to merge the bug fixes back to master, and meanwhile, work on the next branch starts here. So bug fixing on the release candidate and starting the next sprint starts at the same time. And then at some point when it's ready, you move it to production. The worst wait we had in this bug fixing period here was 3 weeks. So you're doing 14-day sprints, and you're spending 3 weeks after the sprint is done getting that thing bug fixed to go ready to go to production. You can imagine what kind of queues that gives, and how can you control the 14-day sprints. This was really frustrating, the situation we had with this kind of Git control. We had some basic tooling, so we had Git, we used GitHub, we had tasks and stories in Jira for controlling what people are working on. We had quite a bit of automation already. So we have good test coverage running through continuous integration server that runs the tests on every commit. And we could deploy basically at the push of a button. So these were all nice things that we already had before we did continuous delivery. So we also had, in the process, we had daily stand-ups. We did groomings, where we cut the scope down of stories to make MVP deliveries, minimal viable products, small things, deliver small chunks. We did estimation, planning poker, and we did burn down charts in Jira for the sprint. We had sprint retrospectives discussing what we had learned and how we could improve and improving. Code reviews were something we always did. And we had a department stand-up where the whole economic was together at a department stand-up. So on the Debitur product that we're working on for the really small businesses and freelancers, we work on Node.js and MongoDB like Jonas mentioned, and economic is a completely different product on Microsoft SQL Server and .NET, and stuff like that. So we were all having a meeting together. So this thing I'm going to show you now took 2 years for us to actually accomplish. 2 years. That's how long it took. Now you're supposed to laugh. It's the same slide as before. Nothing happened in 2 years. So we had the same thing. We were busy, and we were trying to. I was saying, CTO was saying, "Can we do continuous delivery?" I was saying, "We need all of this stuff," and I was still not team lead. But then enter the warriors. Alex and I become team leads. So we're the warrior here, and we're going to fight this monster. This is the monster. Behind it, the pot of gold is that we want. This is where continuous delivery is done. Behind this monster. So we need to fight it. So what happened? 14 days. That's what it took. Then we were running continuous delivery. Actually, we were doing it in 2 days, but it took like a full 2 weeks before we were like comfortable with it. That's how long it took. And so after this small intermezzo, there's gonna be a break, and then we do the rest. But now I want to just illustrate why we could do this in 14 days in a bit weird way. So please bear with me. Jonas, I asked Jonas to volunteer before. He doesn't know what's going to happen now. Can you stand over here, Jonas? Of course. So maybe you need to take off your glasses. It's not bad. Yeah. So I'm going to illustrate what we did to conquer this monster. So I have some props. Can you put this on, Jonas? Maybe. Oh, no. Okay, this is the monster. He's hiding the pot of gold. Why is this a monster? Why is this something we need to fight to conquer? Well, Just stand there, don't do anything. Well, he represents change. He represents a lot of people changing their everyday work, influencing a lot of people. He represents maybe some legacy code without tests, all kinds of obstacles for you doing continuous delivery. So how do we fight a monster? I'm over here, I'm busy programming. I don't want to fight monsters. Let me program, I'm doing features. We need to fix some bugs. How do we fight a monster? That's correct. We need a sword. But guess what's going to happen now, Jonas? So what me and Alex did was we actually grabbed the sword, turn around a bit, and now facing me. Then we just killed the monster. Now I'm at level 82 paladin. You're like a monster. Oh no. You have 1 hit point. Stand, scream a bit. Okay. So what other powers? Just lay there. You're dead. We killed you. So what other powers does this monster have? Anybody here who has some obstacles getting continuous delivery in their company? Just shout it out.
It has more than one head, probably.
It can breathe fire. Maybe a CTO who doesn't want to do continuous delivery. Then your monster has got to have more hit points. You've got to hit it again. Right? You've got to really beat the shit out of it. Okay? Anything else? What is keeping you from doing continuous delivery? Management. Good. Anything else? Human rights. It's a monster, it's not a human. Okay, thank you, Jonas. Thank you. So that's of course, thank you, Jonas. Give him a hand. This is of course a reason why I demonstrated this in this crazy way. Thank you. And the reason is I normally don't do that kind of thing. So I was getting out of my comfort zone to demonstrate what we did. And that's what you got to do to introduce these kind of changes. You've got to really want it, and you've got to get ready to get out of your comfort zone. This is going to influence a lot of people, and when people are being told that things are changing, it's really bad. And it can require you to find your sword instead of just programming. Maybe not literally, but you know what I mean. So the first thing we did was just have a really long talk, me and Alex, about. Alex was like, "Yeah, we're just gonna do some pull requests. It's not gonna change a lot of things. Just do this small thing." And then we had a really long talk, and we realized this is actually gonna affect the developers, the QAs, the POs, even the support. They used to have getting like delivery every 14 days. Now all of a sudden things are just gonna pop up all the time. This is gonna affect a lot of people's workday. So we took a deep breath and said, yes, we're going to do it. We took our swords. And we pointed at our coordinator. That worked really well for us, that we just said, Alex, whenever there are questions, whenever there's anything not working, whenever some stuff is not clear or problems, everybody just go to Alex. And he will sort you out. Did a lot of communication. So almost every single day, when we did this change, we had like half an hour with the team discussing what didn't work, what worked, and then we wrote down our process. Before that, we didn't have our process written down anywhere. So when you started, you just kind of picked it up as the others. But this time, we actually wrote down what we were going to do in doing development, so new people starting actually have a place to go to see how should I develop when I'm here, and we adjusted continually. So we did automation when we had pains, stuff that wasn't nice, stuff that was painful, but we did it in a kind of reactive way. Instead of trying to figure out all the pains before we started and automating all kinds of things, we actually just tried doing it. Of course, we used what we already have. You saw our baseline where we were starting from. We used that, but we didn't do anything anything major with automation before actually starting. And then we fixed the pains as they popped up. We kept it really simple. So we didn't want to build like this huge automation monster could do anything and just everything was automated and running really nice, but really complex. We wanted to keep it as simple as possible and only fix the pains that pop up, and only if they're really painful. And the small pains doesn't need maybe automation. Maybe we can just change a little bit. how you're doing things, and the pain will go away. Or maybe you can live with a little pain. Everybody lives with a little pain somewhere. So keep it simple, fix it as it pops up. This is how we did it. So at the core of the change was how we use version control. So you remember the two long-lived branches, master and release. What we did now is instead, this is really simple. Master, this is production. Time is going forward, moving down. These are branches, these lines are branches. When you want to start a feature, you create a branch, and then you do your commits with these dots going down. So first feature 1 is started, then feature 2 is starting work, and then feature 3, and this is maybe just a bug fix. It's just one commit, and then it's merged to master and deployed. Every time you merge to master, you deploy to production. Master is production. And whenever somebody merges to master, all the other branches merge that change to their feature branches. And then they continue work, and then they merge to master and deploy, and that gets merged to all the branches that are currently in progress. It's actually quite simple, the way we do it. So this was at the heart of what we were doing. So we had Jira, working in sprints in Jira. So where you have, before this sprint gets done, you have a backlog full of tasks. You take some of those tasks after they've been groomed and estimated and put them into a sprint that the team commits to doing in 14 days. And once the sprint starts, everything starts over here in the to-do column. And then when a developer starts working on a task, he moves it to in progress. So this is not our board. This is one I had to take from economic because I didn't have a historic one. But we also had like subtasks, groomed stuff into subtasks that we were moving around. Once the developer's done with the feature and thinks it's ready, he moves it to review. So this is how we used to do it. And once you get review, maybe it gets rejected and moves back, and then you discuss the review comments, and then you move it back to review. And once it gets approved, it goes to QA. QA tests it. It's okay. Maybe they reject it. You have to do another round of bug fixing. Maybe does the bug fix have to be reviewed? Maybe if it's fundamental changes. And at some point, QA says okay, and it moves to done. Once all of these tasks have been moved to done, you have a release, and then you release, merge that to release. So this is how we used to do it. And we tried to use Jira with this new way of going continuous delivery, which is more flow-based. It's not, you don't have like sprints, 14 days. Everything is just in one end, out the other, in this continuous motion all the time. So these periods set doing the flow-based thing just didn't work in Jira. If you want the details about, we really tried, if you want the details about why that didn't work, and if you're using Jira, Sebastian, our PO, put your hand up, he's there, go ask him when we're done. He knows all he was the one fighting with Jira. We were many people trying to help him, but he was the major fighter. So what we did instead was we used a tool called Waffle.io. So this is also in the very keep it simple spirit. Waffle.io is just a view on top of GitHub. And all of these tasks are just issues in GitHub, or maybe pull requests. The backlog is here. So in the other picture we had like a backlog, then we had like 4, 5, 6 states, and then we had a state at the end which is now it's deployed when the thing went to production. So maybe 8 states. This is the full set of states we have now for a task that we're doing. It's on the backlog. It means it's an idea we want to pursue. We groom it, we add detail, UX, adds the pictures, the mock-ups, whatever's needed to be done for the developer to pick it up. Once it's in a state where any developer can pick it up, we move it to ready. The developer picks up the story, moves it to in progress, and the developer keeps that story until it's in production. When it's over here, it's in production. So now we have, all in all, the whole process has 4 states for a task. That's all. This also did a real change to the roles that we had in our teams. So the QA and review columns were like handing over stuff to others to do, and QA, now you're responsible, now you're responsible. In this new model, the developer himself is, or herself, is completely responsible. Once he starts a task, he's responsible for it until it's in production. He takes it all the way. There are no handovers. He asks for code review, but it's still his task. He can ask QA to help him test the task, but we also redefined the QA role from being people who actually do the testing to being people who specify, if you want to test this, maybe these are some good test scenarios, and then go do it yourself. On major things, it's up to the developer to decide. Maybe he wants also QA to help test, or maybe he wants the whole team to do. He's done a major refactor. Maybe he wants the whole team to help test and do a bug bash or something. We try to avoid that, but sometimes it can be necessary. It's up to the developer to ask for the help he needs to have the confidence to push this to production. So this change from handing over to a reviewer, handing over to a QA, and somebody else being responsible for the last part of the journey of that task, to you actually seeing this all the way through to production, and even having responsibility for it if it fucks up in production, and fixing that. That was a really tough change. That was, for a lot of developers, really hard to do. Some of them really loved it. They're like, oh yes, this is just like when I was in a startup. I had full responsibility. You work on maybe side projects, or you've been in a startup. You don't have QA. You don't do review of everything. You use your common sense. What is needed for this thing to go into production? What is actually necessary? So we reduce the waste of having forced things, and you put responsibility on the developer. That's like, when you put the responsibility and the power to push to production, you get both the responsibility and the power. Then that's what we think is a nice way to work, where you actually can take a lot of responsibility and you get a lot of power. So to define what you're going to do on this thing, what you think is necessary. Major change, tough. So feel free to ask questions if you have them. Yeah?
How did that work for your QA department, so to say, taking away some responsibility?
So they had a really hard time not helping people test. But some developers test themselves. Some still have QA test for them and not taking the full responsibility. Right now we are like, this is also something you can choose as a developer, what you're comfortable with. That's the way we're looking at it now. We want the QA to do the help with the test ideas, and we want them to not be testing. But we don't have any rigid rules that says they can't do it. I'll get more to what changed for the QAs. But in general, I can say that moving to continuous delivery gave much more confidence in quality from the QA department than we had earlier. They were much more confident when we were releasing stuff that this is going to be okay. Because it was small changes compared to a big release with 10 developers working for 14 days on the same thing. So, yeah?
How did that change your grooming, story size or shape of stories?
Yeah, so I can take it now. Our grooming, we stopped doing estimations. What we do instead is when we take a story in, we of course discuss the details of it, and then we try to reduce scope to something that you can do in maximum a week. So we don't do anything that you can't do in a week. Sometimes we are wrong, sometimes it takes longer than a week, but we try to keep it as maximum a week. And then you do maybe sub-deliveries on the story, so you don't do all of it all at once, but do some small deliveries. And that's the way the grooming. So the grooming went from being very drilled down and very high detailed, very small tasks, to actually moving a bit up in the abstraction and not being as detailed in the grooming. Yeah.
How do you handle release to production with these partial tasks that doesn't when it's not a full feature that you implement?
You make the partial task a full feature. That's what we've done. We can do that. I don't know if you can do that, but we can do that. We reduce it to something that actually makes sense to deliver. Maybe the change is only in the API, not in the web client. So the API has some feature that the web client doesn't have, and the web client's going to get it in like a week or 2 weeks. But we try to reduce it and generally cut it down into something that makes sense to deliver. You can, of course, hide stuff with like feature flags, but we don't do that very often. So usually we can make something that makes sense. Yeah.
So what is it about your particular market and customers that makes that possible? Because that's one of the very common challenges with collective continuous.
That's really hard for me to answer. I've only done it like we do. So I would need to know what the problems were before I could answer that.
Well, what is it about your customers that makes it acceptable for them to get bite-sized deliveries all the time?
To get
Bite-sized deliveries all the time. Some customers, I know I sound very old-fashioned when I say so, but I don't care, you can take this all if you want. Some customers may be annoyed by that and not want it. What is it about your customers that makes that something they appreciate?
Well, we're not radically changing everything every time we push, right? We're making really small adjustments. So, I don't know, we just did it and I thought it made common sense. That's really nice for us. I don't know, Alessandro, did we have any pushback on user voice or anything like people saying we're changing too much?
So we do get pushback readily, and often if we make a feature that we thought was an improvement, but it turns out not to be. But the cool thing about it then is a small thing we did, we get an immediate reaction on the phone, and we can quickly change it. Okay, so I think the fact that when you start delivering small increments over a week, people won't notice the difference. I mean, yeah, the bottom change. Hasn't this bottom always been like this? You don't really think about it. So I don't think we have seen any problems apart from maybe some features wrong each once in a while.
Yeah. Yeah?
How about major refactorings?
Yeah, those are a pain, no matter what you do. So you do them in the branch, and you merge, and you fix the merge conflicts, and you keep going in the branch, and then at some point you merge it to master, but that can be really painful. Yeah, if it's a major refactoring. Yeah?
How do you inform your customers about new updates? Do they just appear, or do you kind of give them notice?
Depends on whether or not we have been remembered to tell the support that a new feature is coming. Usually they know it's coming pretty soon. They know what's coming, and then we ping them when it's like, okay, it's coming in 5 minutes. You got this new feature that we talked about, or maybe in an hour. But usually it's very short notice we give them, because we don't know when it's going to be ready, and as soon as it's ready, we push it. So they get like, but they know what's brewing. Yeah.
So are you considering using this approach for economic as well? Or do you consider that being a more high stake or high security product?
So Jonas that I slayed, he was team lead before me on economic. No, so or on Debitur. So that's not the reason I slayed him. He's a nice guy and I thought he could take a joke. He's now on economic. And trying to move this forward on economic. So we moved from 2-week deployments to 1 week, right?
Yeah, and we're pursuing that actively right now. There are some technical things and lots of bad excuses and good excuses as well that keeps us from doing this right away, but it's something that we're going for actively. So,
so his monster is bigger than ours.
Yeah, sure. I was just thinking that it's a different user base, right? So you have like I guess you have more like accountants on economic, whereas Debitur is more like, common users, if I can put it that way. So I would imagine that an accountant that uses this system every day would be annoyed by a small change in the feature from one day to the other without knowing that this actually happened?
Usually when you do something, you do it actually to improve, right?
Yeah, yes,
You
sure,
don't
but
change it to make it worse.
No, but you
So
need to know.
usually the reaction you're hoping for and the one you've tested and maybe user tested this, we actually just test these things on real people before we just push it on everybody. So we have a pretty good feeling this is going to be something people are going to like. This is going to be nice. So most of the time it's going to be received really well. But of course there's a small risk, and accountants are not the people who are most favored of changing
No, exactly.
their software all the time. Of course, that's going to be some, but ultimately you're improving. You're improving stuff, and you're making small changes, right? You're not changing the whole thing like we did with the skin. That was a big change.
But anyway, I think there's a big difference between like workflow disrupting features and then like continuously improving things that, you know, add to something without changing what's there already. And the last type of changes are generally well accepted, whereas the workflow disruptors are, you need to plan them a little bit ahead and prepare people, and especially our support department downstairs. So yes, there is a difference between the two products, but I don't see it as impossible. We can pull it off. I'm pretty confident.
Okay, a lot of questions.
How many feature streams do you have?
How many?
Yeah.
Uh,
What's the limit?
there's no limit. So a developer can work on 1 or 2 or 3.
So if I'm
So-
working on one feature stream, but every time someone else they push to production, I pull this in.
Yeah.
Does that disrupt that person a lot if their story is longer?
I'll get to that. Yeah. So yeah, this stuff we need to improve. Maybe if I go on and talk a little bit more about some of the other slides, some of your answers, your questions might get answered, then we can take some more questions later. So one thing we also changed was like the environments. When you have like doing sprints, there's this staging environment where you're doing the testing on. Maybe you have 2, maybe you have 1. And if everybody here, if Anton and Mirza and Phil here are all having their own branch, they can't all be on staging at the same time. So then they'll have to take turns at using the staging environment. That's going to be the queue with the cars going around and things stopping. We don't want that. We don't want queues. So we actually built something for continuous procurement, which is just a fancy way of saying you can get your own server. So I just want to demo that. So let's hope this works. So here I have a pull request, just an old one I was working on. I had 2 people, here are the changes. I had 2 people review it because it was kind of important, this thing. And we discussed it here, and now we're ready to deploy. So what you do is, you talk to this guy, Economic GitHub. He's a user on, so this is deploying to a staging environment. I want to test this not just on my computer, but on a production-like environment. So I can say, Economic GitHub deploy, please. Let's see if this works. So this
You probably can't because it can't merge. You could try to merge with master.
it's not merging, it's just deploying this branch, so that doesn't matter.
Yep.
There it is.
Redeploy.
So I get this comment where I have this link I can click, and once you enter it, oh, it's already built. So yeah, if you enter it faster than I did, you can see the application actually building and deploying my pull request, my branch, and everybody gets their own branch, and they can deploy whenever they want to a staging environment. So that's a piece of tooling we built. So the situation looks like this, where each developer, Hanson here is working on a pull request, he's deployed it to the staging environment here. Mirza is working on something, he's having QA look at it on the staging environment. And Phil, he's really busy, he's having QA look at it on one thing he's working on, and then he's working on another thing at the same time, so he's got two environments going. Max and Alex are working together on a feature, so they're sharing an environment, a branch on this environment. So Phil can have, anybody can have as many environments, as many pull requests open, or as many branches open as they want, and you can share as many people working on one thing if you work on a feature together. This is parallel compared to the other picture. So this is something we learned we needed to build, that we built.
I have a question for that one.
Yeah.
Do you have like a full data set for each of these environments, staging environments?
So right now, we also have microservices. A full deployment is actually a lot of processes working together. Right now, this is just the main application. We are working slowly on getting, when you deploy here, it actually gets the full suite of microservices and maybe the database. All of these share the same database with the same logins and stuff like that. So right now there's no pain here for us. This works for us. But adding the microservices to the deploy is probably going to be a good idea as we grow in complexity and have more and more microservices, having to manage dependencies. Yeah, it's the same database. Long answer. So how we changed how we do continuous integration with pull requests, some tooling around that. So the developer pushes his code to GitHub, TeamCity picks that up, and then this server is in-house right now, but it runs the tests for that commit in Amazon, and gives you an answer whether or not the test pass. If you want to deploy, you run something here, start a job here where the TeamCity agents pull the code from GitHub, and then they push it to production or staging. So these also run deploy scripts. It's just to give an overview of some of the top stuff I'm going to show you now. This is like the base architecture of how things run. So one thing you get from TeamCity is, this is really hard to see. Okay, I hope I can tell you what it is. These are all pull requests. Each pull request, whenever you push to it, push something to GitHub on that pull request, the test suite, the whole test suite is run for that pull request on each commit. And before we had a situation where everybody was working in master, and when the TeamCity turned red on master, it's like, everybody stop what you're doing, we need to fix master, it's red. And this, here you can see some pull requests actually have some problems here with some test failing. It doesn't matter because it's all parallel. As long as you turn these green before you merge to master, you can have it red. You can go home and let it be red. You don't need to fix it before you go home. And it's all running in parallel instead of being like a synchronization point. And it could really be painful when that continuous integration so turned red. Everybody needs to stop what they were doing and help fix it if it was something complex. So that changed. On GitHub, with the pull request, you actually get an integration where you get this small, where you can see the status of the test run on that branch. This is good for QAs, so if QAs are called in, will you help test my branch? I look here and see, oh, this is an X. Go fix that before I spend my time testing your crap. Okay? As you can see here, the labels from Waffle.io are just labels here on GitHub. So this is in progress. In progress. Waffle.io was just a layer on top of GitHub. So everything you can see in the task board, where we had Jira before, but now have Waffle.io, you can see directly on GitHub also. And if you scroll into the pull request or the branch that the developer is working on, you can actually see the status in there. You also saw that on the one in the demo, which was red. Now here's a green one. That's really nice to see that. So I don't want to go into detail about what's on this slide a lot, but just mention that we had a lot of pain with the Team CD agents and getting this thing stable. Some of the pain came from that we used to have one Team CD agent, and it just kind of grew. The software we needed on it just got installed. Now we wanted to have 3, so we did a chef script to generate that Team CD agent, actually figuring out what was needed and going through all this, oh shit, we need that, we need that, we need that, as an iterative process. It was really painful, also because we were dependent on another department doing the chef script for us. So one thing we learned was we took the responsibility of the chef script ourselves for our Team CD agents on the team, so we don't have this dependency between departments. We also have full responsibility of the Team CD builds that we have. Any developer can go in and change the Team CD builds. It's the responsibility of the whole team that stuff is in good shape and works like we want it. Now the Team CD agents are also our responsibility. And the microservice thing I talked about, where we have all these microservices, getting that up and running on the Team CD agents was really painful. So we actually spent quite a bit of effort getting this up and running. And I think today we have problems with stuff on the Team CD agents. It still pops up every once in a while. It has a cost doing this kind of thing.
But you went live without having it, right? So I mean, you started the process without having chefified Team CD agents and all of that stuff.
Yes, yes. This is something we did along the way, like the lessons we learned and stuff we improved. So deploying. How do we coordinate when you can deploy? Because we agreed we don't want like people just deploying on top of each other all the time. That's too scary. That sounds really scary, just deploying. So the first solution we had was, Alex, you'll coordinate the deploys. Kind of doesn't work when Alex is on vacation or sick or something. Just having one guy. Also, it took a lot of his time. Really didn't work. So how would you, does anybody have any suggestions how you could coordinate people working on these pull requests and you want to deploy to production? Have any ideas how you could coordinate that?
Make a booking system for slots.
A booking system for slots?
Yep.
Yes?
1 deploy per hour?
1 deploy per hour? Okay, I thought you guys would do like super fancy advanced automation stuff. But it's kind of what we did, what you're talking about. We just did a HipChat room where when something's deployed, it gets a notification automatically. And then you just say in there, I want to deploy, please. And then when you're done, the tag gets put in there. It's kind of a queue, right? It's a queue. We don't want a queue. It's bad. So what we're going to do, and this we haven't done, we've been discussing this. So our monster still alive. Jonas? No? Okay. We still need to fight the monster. What we're going to do is, like, we have this rule that the reason the queue appeared is whenever you merge to master, what you merge must have master merged to your branch. That's the thing you asked about. Isn't that annoying? Yes, it's annoying. Having to merge every time somebody merges to master, you have to merge it into your branch. What we're moving to instead is like, you do that as a developer when you feel it's necessary. Remember, we encourage you to do it as often as possible. And do it definitely before you merge to master. Or before you want to deploy. But having master completely merged doesn't need to be a requisite. As long as the merge you're doing into master can be done without conflicts, without human intervention, as it's an automatic merge with no conflicts. That's what we're going to change, that's what we're going to allow, but we haven't done that yet. I was pushing Alex. So what we're going to do is, like, when the developer feels stuff is done, we're going to have some kind of button you can push, and then it just goes straight to production. Straight to master, straight to production. Completely automated. That's not where we are right now. We have the HipChat thing. Yeah?
A small little curiosity. GitHub actually maintains kind of a special branch where it simulates a merge with master. So if you want to run your tests on something that updates every time master updates on your pull request, you can do that. So we're using that on Economic to to kind of run the full test suite on the kind of the merged pull request without actually doing the merge, and the developer doesn't have to do anything.
Yeah. We're going to have to build some. Yeah.
If the QA has done testing on two different
QA doesn't do testing. You do the testing. The developer does the testing.
Right, right. If
Yeah.
the developer does testing on this branch, and another developer does testing on another branch, and they automatically merge,
Yeah.
but they still conflict. Not in like in source code, but
Yeah.
in logically.
Yeah. Yeah.
Do you have that kind of problem, or?
So this is not what we're doing. The answer is we'll see. We're going to try and see what happens. My gut feeling is that's not going to be a problem. Because if you got a good test suite, it should catch that, the logical conflicts. Otherwise, you haven't done a good test suite. So you can maybe argue something in the GUI can change that you can't automatically validate. Something can change, and it's like, okay. So the chance of that is probably really, really, I have a really hard time. So one thing I have thought about it. So one thing that could happen is, if you have a CSS class in your code that doesn't get used, and one guy starts using it for something super important, and the other guy in the other branch says, oh, this doesn't get used, and he deletes it. Then you can have like this kind of situation where then all of a sudden the GUI is fucked. But I'm having a hard time seeing that happen, and if it happens like once every 2 years, I think we can live with it. But we'll see. It's going to be an experiment. So this is how we deploy to master. Once you've got the green light in the HipChat room, you merge yourself, you squash your branch to master. Then you click this button right here on TeamCity, and it deploys your stuff to production. And then you watch the tail. The tail is like the latest errors from production that we can see. And we live and die by that tail. We watch it all the time and keep an eye on it.
It's down there, right?
For what production's doing. Yeah, don't show it.
Okay.
No, it's down there on that screen, right there. It's that one. It's got some errors in there. So when you deploy your stuff, you look at what's happening in the tail. We try to clean it out so there's no noise in it. Right now it looks like it has some noise. But so you can easily see if the stuff you just deployed, did it fuck up in some way. And you will see it quite fast. It will, if you fucked up, it will appear quite fast most of the time. And then you can fix your error. So we try to move forward instead of doing a revert of your commit. It's easy to do a revert because it's just one commit and you just pushed it. You can easily revert it. But what we always try to do is first see if we can move forward. And often, because the complexity is so low in what you're doing, in these small iterations, you can move forward. Compared to if you have like a 14-day sprint with 10 developers working and then you push it to production, I mean, having to revert that, all of that is like, that's really super unnice. But sometimes you may have to. And also trying to fix it, like finding out, was that your bug, or maybe that's my code, was it yours? Or that's a nightmare, yeah?
How do you make the tail? I mean, do you run tests in production, or?
So the tail is made by our logs, go through Logstash to Elasticsearch. We have Kibana where we can search those logs, but the tail is just a query over Elasticsearch data.
Okay,
so it's all the logs.
Really using the product.
Yeah, it is. It's real people have experience in errors when stuff pops up there.
So you don't run any automated tests in production, just to see.
In production?
Yeah, in production.
No. All our tests are run before we push to production. Yeah.
Do you ever do partial deployments to 1% of the customers, etc.?
Economic does some partial deployments. So Debitur, we haven't had the need for that yet. But it will probably come at some point as we grow. Yeah?
How do you relate
Oh, that's a completely different talk. So in short, we don't patch the database as the first thing. What we do is we encode transform data so it looks like it's been patched. After that's run for a while, we actually do change the data, and we have a way to revert. We have a tool called Mongo Patch for the Mongo database, which actually records everything you need to revert. We've never done that, but it should be possible. And we do some steps, intermediate steps, where we do partial things. See me afterwards. I can tell you the details. It's kind of hard to explain in such a short while.
But Mongo Patch is open source?
Yeah.
So
Mongo Patch is an open source node module that you can use to patch your database. There's a completely different, long story about that. Okay. So you watch the tail, production's good. Move on to the next task. So I'm going to sum up some of the things we've seen. First of all, in our experience, did moving to continuous delivery deliver solutions cheaper, faster, with better quality, with bigger and better teams, with more focused and less stressed employees? Yes, on all of it. Some more than others. Some things more than others, but it did. It really did. It's improved things a lot. We haven't measured scientifically, so you're gonna have to take my word for it. That's the feeling all around. And I've got some nice juicy bits that's coming later. Some nice juicy bits. First, I'm gonna see how we change the process. So we still do daily stand-ups. We still do groomings, and daily stand-ups, we changed the format. We did this thing where 2 developers are responsible for actually doing stand-up, and they decide the format. And then we do 2 developers at a time and change. So we developed a new kind of format, which is much nicer. But we still do groomings and MVP deliveries. We don't do estimates. We don't do planning poker. We don't do burn down charts. We don't do sprint retrospectives, but we still do retrospectives, and still once every 2 weeks. We still do code reviews. We skipped the department stand-up and replaced it by ad hoc knowledge sharing across the team when we have something that actually makes sense for everybody. And then with all of this extra time we got from all these meetings that we don't have to have coordinating all of this release every 14 days, we spend a little of that actually doing weekly knowledge sharing sessions on the teams on Debitur. So that's the main things that changed in our process. So some things that changed, like this juicy bits. This thing with when the QA is testing something, we were all working in master, and the QA reports you've got a bug in your feature, and then the developer's like, that's not my bug, it's somebody else. Everybody else is doing something causing this stuff to happen. That thing completely disappeared. I mean, you have just your own work in that branch that's being tested, so you know if it's fucked up, it's you. So that's really nice. That's really nice. A new thing, so POs, product owners, are always like, when can we deploy? Is it ready? Let's go. Production, go, 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 go. That's like the PO's job to be like that. But we actually heard, and they still are like that, but we actually heard some new words from the PO that we've never heard before, which was like, what? That's already in production? That was really nice, completely new thing for the PO. And a thing that the QAs never, ever, ever said before was, let's deploy. Push already. Let's go push it to production. I mean, when you've got a QA pushing you to push your stuff to production, you know that quality. That's good. So these are just a few highlights of what changed in our day-to-day work. So that was it for this talk about continuous delivery war stories.